Coordinate computation. We need to calculate coordinates, and coordinates are very important for any engineer in any branch. So let's start by what are coordinate systems and why we use coordinate systems. Points while using coordinate systems are tied relative to a certain axis, not relative to each other, or not tied or related to each other. So there's no accumulation of errors. If points are tied to each other, then accumulation of errors will occur. If any point is mistakenly measured, then this will affect the next point and so on. But if each point is defined relative to a certain axis, like x or y axis, then each point is defined discrete relative to these axes. Also, coordinate systems are beneficial as it's easy to use with computers and easy to know the storage of data. If you're tying points together, then you don't know how many angles or distances you're going to measure. But in case you have 200 points and each point has two sets of coordinates, each set occupies, say, 20 kilobytes, for example, then you have 200 by 2 by 20 by 200, that's around 8,000 kilobytes, which makes 8 megabytes of data. So it's set the amount of data you need for all points. Another important issue, why do we use coordinate system, is to transform coordinates between different systems, or to transform between phases of any project, phase 1 and phase 2, or if it's an international project connecting countries together, then you can transform between coordinate system of a certain country to another country. This is all done by using coordinate systems. What are the different types of coordinate systems? There are the geographic coordinate system, الإحداثيات الجغرافية, or geodetic coordinate system, الإحداثيات الجيوديسية, which are 3D, phi, lambda, and h, or x, y, and z. X, y, and z are metric, while phi or lambda are angular, and this is because x, y, and z usually in space are large in values, so it's easier to deal with angles instead of distances. And what we'll focus on are the plane coordinates, which is basically either polar coordinate systems, r and theta, or Cartesian coordinate system, x and y, or basically from now on we're going to speak as it's easting and northing relative to the north direction. Let's go now to the plane coordinate. The plane coordinate system, as we mentioned earlier, we have the polar coordinate system, الإحداثيات القطبية. Each point is defined relative to a certain origin, and the distance from the point to the origin is measured along with the angular between the polar axes and the line joining the origin and the point. So each point is defined by r and theta, but this point is not regularly used. The one usually used is the Cartesian coordinate systems. Basically, each point is defined by two sets of coordinates, the easting coordinate and the northing coordinate. The easting coordinate is the distance from the point, or the perpendicular distance from the point to the north direction, and the northing coordinate is the perpendicular distance from the point to the easting axis. And it's called الإحداثيات الشرقية والإحداثيات الشمالية للنقطة. This is for a single point. What happens if we have a line? Basically, a line is formed by 2 points. Each point has its two sets of coordinates. So point A has easting and northing, point B has easting and northing, and what we want to get is the components of the line. So a point has coordinates while a line has component. This line could be like a pipe, a road joining 2 points. So what we want to get is the components of the line. The components of the line are the projection of this line in the easting component and the northing component, or in the easting direction and the northing direction. Remember that all this is plane, so this is a plan view. The easting component, as you can see, delta EAB equals EB minus EA, and delta NAB equals n of point B minus n of point A, which we call them the easting component of the line and the northing component of the line, or sometimes we call the departure and the latitude. Furthermore, let's speak about the whole circle bearing. الانحراف الكلي. Sometimes they call it the bearing, sometimes they call it the azimuth. For any line, if you want to get the bearing, we'll draw a parallel to the north direction, which is anywhere. We're going to deal with it for now, and then we're going to skip it at the end, and we don't need it at all. But let's focus on that we have a north direction. If you want to get the bearing of the line AB, then you draw a parallel line to the north direction. The whole circle bearing is the angle from the north direction to the line, measured always in a clockwise direction. If you're going to divide the axes of the coordinate system into 4 quadrants, then this is the first quad, this is the second quad, the third quad, the fourth quad. You will find that any line having a bearing of from 0 to 90 degrees will be in the first quad, 90 to 180 in the second, 180 to 270 in the third, 270 to 360 in the fourth quad. However, you should always remember that what sets the bearing of the line and the value of the bearing are the components themselves, not the coordinates. So if you these 2 points could be in the third quad and their coordinates are negative, but their bearing could appear as if it is in the first quad. So what sets the bearing of the line is the value and sign of the components of this line, not the coordinates of the points or where the points are in these 2 axes. Also remember that alpha shouldn't be a negative value. If it's a negative value, then you add 360 degrees. If by chance sometimes happened that alpha is greater than 360 degrees, then you subtract 360 degrees. 360 degrees doesn't do anything, it's just one cycle, so it doesn't add up to anything. Relation between forward and backward bearing. It depends on how you're looking at the line. Say this is a pipe and you're dealing with this pipe from point A to point B. So if you're measuring the bearing at point A, so we call this the forward bearing, الانحراف الأمامي. And if you're measuring it from point B to point A, then we call it backward bearing. If you're considering the line as AB, then forward bearing is alpha AB, backward bearing is alpha BA. And if you're considering the line from B to A, then the forward bearing is alpha BA and the backward is alpha AB. It doesn't matter, it just you need to know how you're looking at the line and what's on the left and what's on the right. What's the relation between the forward bearing and the backward bearing? We want to get a relation between the forward bearing alpha AB and the backward bearing alpha BA. This relation can be distinguished easily if you're going to extend this line. So basically this angle equals to this angle. So this is alpha AB and this is alpha AB and this is alpha BA. Alpha AB, angle from north direction to the line. Alpha BA, angle from north direction to the line. So this is alpha BA and this is alpha AB. So the relation between alpha BA and alpha AB is 180 degrees. 180 degrees. Do we add 180 or we subtract 180 degrees? Well, if the bearing that you have is greater than 180 degrees, then you use the minus sign. If the bearing that you have is smaller than 180 degrees, then you use the positive sign. It doesn't matter even, because if alpha AB equals 200 and you added 180 degrees, then alpha BA will equals to 380, and we don't have anything greater than 360. So what you're going to do, you're going to subtract 360 degrees, so you will get it as 20. It will be the same value if you used the minus sign, so it's 200 minus 180 equals 20. So the relation always between the forward bearing and the backward bearing for any line is 180 degrees, positive or negative. The quadrant bearing. The quadrant bearing is another form of the bearing of the line. الانحراف المختصر, quadrant bearing or reduced bearing. If you're going to go to the definition of the quadrant bearing, it is the angle between the line from the north direction or the south direction to the line clockwise or anti-clockwise, whichever is closer. So if the line is in the first quad, it's easier to measure it from north and go clockwise. If it's in the second quad, then it's from the south anti-clockwise. If it's in the third quad, then it's from the south direction clockwise, and if it's in the fourth quad, then you measure it from the north anti-clockwise. So you'll always find that the quadrant bearing is from 0 to 90 degrees, but this is not enough. You need to distinguish the quadrants that you're in. So the first quad is northeast, the second is southeast, the third is southwest, and the fourth is northwest. So for example, if you have alpha equals to 140 degrees, so this is the third quad, so this is the 240, and you need only this, so 240 subtracted by 180 degrees will get it 60. So 60, you're going to write it down, you're measuring it from the south, 60 degrees towards the west. Another example, if we have alpha equals 300, then this is in the fourth quad. So fourth quad, then 360 minus 300 equals to 60, and you're going to write it down as north 60 west. If you have a quadrant bearing S40E, then this is in the second quad. So 40, this is 40, and you need the whole circle bearing, so you need all this. So 180 minus 40 equals 140 degrees. So alpha equals 140 degrees. So it's easy to distinguish between the whole circle bearing and the quadrant bearing. The whole circle bearing is from 0 to 360 degrees without any letters, while the quadrant bearing is from 0 to 90 degrees, having the letters indicating the quadrant of each line. Forward to how to calculate the angle between any two bearings. For example, if we have a line AB and a line AC, and we want to get the angle between these two lines. So AB, I'm assuming that this is the north direction. The angle from the north direction to the line equal alpha AB, and the angle from the north direction to the other line equal alpha AC. So if you subtract alpha AC minus alpha AB, you'll get the horizontal angle BAC. Any horizontal angle must be named from left to right clockwise direction. From left to right clockwise direction. If you name the angle properly, so this angle is named BAC from left to right and measured at A, then you can get it easily which bearings is differentiated. You go alpha AC minus alpha AB. Alpha AC minus alpha AB. If you have an angle equals XYZ, then it will be equal to alpha YZ minus alpha YX. Finally, we have two topics remaining. The first is how to calculate the components of any line from the length and bearing. So if we have this case, which is what we did before, but I added some variables. So this is point A having easting and northing coordinates. This is point B having easting and northing coordinates. And this is the component of the line AB, delta EAB, and the northing component of the line delta NAB. This is the whole circle bearing of the line AB, and this is the horizontal length of the line AB. If we have the length and bearing of this line, so sine alpha AB equal delta E over L, opposite over the hypotenuse. Cosine alpha AB equals delta NAB over LAB, adjacent over the hypotenuse. So basically we'll get that delta EAB equals L sine alpha, delta NAB equal L cosine alpha. LAB or LBA, it doesn't matter, but it matters in alpha AB, because alpha AB and alpha BA, there's a difference between them 180 degrees, and so the sign of the sine alpha and cosine alpha will differ. So it's very important whether you're giving alpha AB or alpha BA, and what you're getting is delta EAB or delta EBA. The value will be the same, but the sign will be totally different. From before, we got that delta EAB equals EB minus EA, and delta NAB equals NB minus NA. So if you're going to move EA and NA to the other side, you will get the most important equation in order to get the coordinates of any point you need. So if you want to get the coordinates of any point, what you need is another point of known coordinates, and you connect these 2 points by a line. You know the distance or the horizontal distance between them, as well as the bearing of this line. Not the angle, the bearing. What's the difference between angle and bearing? The angle is between any two lines, while the bearing is an angle between two lines, but one of them, yes, it is the north direction. So this is a very important equation that tells you if you want to get the coordinates of any point in any project, what you need: three things: a point of known coordinates, the length of this line, and the bearing joining or the bearing of the line joining these 2 points. On the other hand, what if we have the components and we want the length and bearing? Or in other, what if we have the coordinates of 2 points and we want to get the length and bearing of this line joining these 2 points? So if they have the coordinates of these 2 points A and B, we can calculate easily the component of the line delta EAB and delta NAB from the corresponding coordinates, and through Pythagoras theorem we can determine the length L between these 2 points, the horizontal length between these 2 points, square root delta E squared plus delta N squared. And this is why LAB is not differentiated from LBA, because the square will remove the sign of the components, whether easting or northing components. Finally, what we want to get is the bearing. So how do we calculate the bearing? The bearing is delta EAB equal L sine, delta NAB equal L cosine. If you divide them together, then you will have that alpha equal 10 minus 1 delta E over delta N, but you have to take care of the sign, because if you don't consider the sign, the calculator will give you just an angle in the first quad. So what you need to do is you will need to get the absolute value of delta E and delta N, divide them together, 10 minus 1 the value, you will get a value that is always positive. Positive, that means it's within 0 to 90 degrees. So what you actually calculated is the reduced or quadrant bearing. How to get the whole circle bearing? You go back to the signs that you removed and check if they were positive, then the whole circle bearing equal reduced bearing. If it was positive, negative, then it's 180 minus the reduced bearing. If it is negative, then it's 180 plus the reduced bearing, and if it is negative positive, then it's 360 minus the whole circle bearing. At the end, you should ask yourself, so do we need the north direction in field, or how will I find the north direction in field? You won't find the north direction in field. What you actually need is at least 2 monumented points of known coordinates. If you have 2 points in field monumented and you know the coordinates of them, then you can calculate the components of these of the line joining these 2 points, and then you can calculate the bearing joining these 2 points. And so instead of having the north direction having a whole circle bearing equals to 0, you will have a line of a certain bearing, which can make you work easily in your project. Another thing is you need to ask is how do I solve any problem in any project, or how do I solve any problem in the exam? You will always have to ask yourself, what do I need? Do I need coordinates? Coordinates will be either given or calculated from the equations in the previous slide. Uh, do I need length? Length could be given or it could be calculated from the coordinates, as we mentioned here. Calculate the components and then you calculate the length, or you can get it through trigonometric function by forming triangles and solving cosine rule and sine rule. Bearing, how do I get bearings? Bearings could be either given or can be calculated from coordinates as given here, or they can be calculated from another line of known bearing and the angle between these two lines. So if you have the bearing of the line AC and you have the angle between the line AC and the line AB, then you can calculate the bearing of the line AB. Always focus on how to calculate or how to obtain the coordinates, how to obtain the length, how to obtain the bearing, and then you can solve any problem in any project or in any exam. Thank you.